So last time we looked at a bit of a shortcut to calculate binomial probability distributions, and this time we're probably going to do an even shorter cut than that. So let's have a look just straight into an example. So 28% of Australian medals won at the Olympics are gold medals. Australia are projected to win 30 medals. So find the probability that half the medals are gold, Australia wins 8 or less, or Australia wins at least 15. So we'll have a look at the shortcut here. So what we're going to do is grab up our calculator. And we're going to go to our standard run matrix mode here. So we're going to run matrix. We're going to press option, stat for statistics, dist for distribution, and binomial. So the first thing we've been asked is half the medals are gold. So if we see down here, after pressing that combination, I've got BPD and BCD. So BPD is binomial probability distribution. So what I want to find is, I'm going to first put in the value I'm interested in. So I'm going to put in 15. So if half the medals are gold, we won 30 medals, that's 15. I'm going to then put a comma in. So the comma is just down here. And after the comma, I'm going to put in the total number we have. So we've got a total number of 30 medals. So 15 is what we're interested in, total of 30. And I'm going to do another comma, and I'm going to put in the probability of a single trial. So 0.28. And I'm going to close my brackets. All right. So what I get is 5.72 times 10 to the negative 3. If I multiply that by 100, I'll get it in a percentage. All right. So chances of Australia winning exactly 15 gold medals is 0.6%. Okay. So quite unlikely. All right, so the next question asks us, what's the likelihood of Australia winning winning 8 or less? So what we're going to do is we're going to have a look at this BCD. That's the cumulative, so that counts down. So the first number I'm interested in, again, is 8, and what that's going to do is count the probability that we get 8 golds, then 7, then 6, and it's going to go all the way down to 0. So I'm going to do 8, I'm going to do a comma, I'm going to do my total again, 30, another comma, and I'm going to do my probability, which is 0.28, and close my brackets. All right, so 0.5. So if I multiply that by 100, it will give me my percentage. So that's 52.8, or we can call that 53%. So it's 53% likely that Australia wins 8 or less gold medals. So more than likely that's going to happen. So the last number we're interested in is Australia winning at least 15 gold medals, which means 14 doesn't count. So 14 gold medals doesn't hit this criteria, but we want above that. Now, what we're going to do here is we're going to use our cumulative again. Oops, that's my dog. We're going to use our cumulative again. We're going to start by looking at 14. So 14 doesn't count, and this cumulative distribution counts down. So this is going to count 14, 13, etc. So we're going to start with 14. It's out of a total of 30. We're going to do the probability of 0.28 and close the bracket. All right, we got 99%. What we're going to do with this is the chance that we get 14, 13, 12, 11, 10, all of those. So the chance we get at least 15, so above that will be 1. So all of it. Take away that answer, shift answer, which equals that. We times that by 100 to get it in a percentage, 0.873. So if you've got, if you're betting on Australia to get more than 15 golds, it seems unlikely. I hope it happens, but 0.87%. Yeah, so that's how we use that bit of a shortcut. So you don't have to use that. You can use either method that you'd like. But that's just a bit of a shortcut. I quite like it. And yeah, hopefully we can have a go at some examples. Thank you. Bye.